We're going to have a little fun today. I'm going to tell you about the game you're going to make. Your job is to make a board game. So I've got two different games here. I've got Foot Race. This is one game, nice and simple. We're going to start, and you can either start, it's two versions of the game. You can start here and finish and be done, or you can start and finish. So it could be just a there game or a there and back game. So there are four different people who can play the game. Or we have, I have Swift Mages, and in this game, the mage's job is to make it here to the middle to defeat the evil sorcerer. So they've got to make it to the evil sorcerer to beat him. So we got on both ends. So two different games. So your job is to create some. You come up with your own. What do you want your game to be? So come up with some game and just use things around your house. So you could use, this is just done on paper, just drawn off on paper. You could use, like, we've got Amazon boxes where that's where this came from, is cutting off the cardboard of Amazon boxes now that we're ordering everything online. Or maybe just paper is fine. Whatever you have around the house to create your board game. And then, creativity is great. That's always encouraged. And then you've got to come up with a way to move. So, here I have a spinner. And then, and we'll talk more about the spinner in a little bit. And then on this one, I got a little fancy. So probably keeping it with a spinner or something where the probability stays the same is going to be important. But in this one, I got a little fancy and have these little cards that you could pull out. I got our little flags for the race, the checkered flags to pull out. So, but we're going to talk about the do's and the don'ts of it, okay? So things you want to do and things you don't want to do when you're creating your board game. So as you create the board game, you want to think about that expected move. That's the whole idea here, is you want this game to be something you play and is enjoyable, but at the same time doesn't last all day long. So it might help you to figure out the expected value of your whatever it is to help you move before you get started, before you actually make the thing. So for instance, let's figure out the expected value of both of my games, and I'll tell you as I was doing it, some things I thought about as I did it. So first, let's start with the Foot Races one. So notice it doesn't have a whole lot of spaces on it. In fact, it only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 if I'm going just one way. It'd be 20 if I went there and back. So, it's either 10 spaces or 20 spaces, just depending on how much time you have to spend with your kid. So, and that's another thing. Especially if you're quarantined at home with kids, think about your audience of who it is that you're building that to play with. Because you are going to play the game with somebody. So, if I had kids at home, and especially if I was like homeschooling them, having to do some math with them, maybe I want a game like this to work with. But if I've got, older kids and I'm just trying to entertain them, then maybe something like this is more appropriate. So think about who you're going to play with, and then who your audience is. Okay, so in this one, I've got some different math problems on each one of my sticks. And I went ahead and did the math. Like this one says 10 minus the absolute value of -8. Do y'all know what that's equal to? What is 10 minus the absolute value of -8? Oh yeah, I like it as 2, because the absolute value of -8 is just 8. And then 10 minus 8 is just 2. So all of these flags are actually equal to 2. If you do the math on them, they're all equal to 2. So there's 1, 2, 3, 4, 5, 6, 7, 8 of those. 8 flags that equal 2. So what you do for this game is you pull out a stick and you figure out the math, and then that tells you how many spaces you're going to move. So in this case, I'm going to move 2 spaces if I pull out any of those 8 flags. So I'm going to put those 8 flags in my little water bottle. Those 8 flags go in my water bottle. All right, let's figure out how much these guys are. So here, this one is -3 plus 1 plus 6 minus 4. Let's figure out how much that is. So -3 plus 1 plus 6 minus 4. How much is that equal to? Yay! It's 0, because this is -7 plus 7, which is 0, or -16 plus 16, which is 0. Yay! So I have 2 flags that are 0. So if we get those, we don't get to move. We don't get to move at all. Then here, let's see, let's do this one. Square root of 16 minus the square root of 25. What's the square root of 16 minus the square root of 25? Yay, -1. So if we get either one of those, we have to go backwards 1. We got to go backwards 1 on that. So 2 flags that are backwards 1. All right, 2 more different options here. So 15 divided by 3 minus 8 divided by 2. That's 1. So I have 2 flags that are 1. So if we get either one of those, we get 1. Y'all are doing great. I commend you. You've learned the developmental part of this class. Y'all got this basic math down. Good job. Super proud. Big steps, big steps. Okay, one more. 2 minus the absolute value of 6. Ooh. 2 minus the absolute value of 6. I don't want to get that one. Or -9 plus 3 minus 2 plus 4. So it turns out there are 2 flags. You're going to tell me yes, that equal -4. Yay! So if I get either one of those, I have to go backwards 4 spots. Okay, so as you're creating your game, what you want to kind of do is decide what you want your expected value to be, and create a probability distribution. You know, in order to find that expected value, you want to create your probability distribution. So here, I'm going to create a probability distribution. We're going to find out what my expected value is. So the first thing we have to do is figure out the different outcomes. And notice that my outcomes, I've got some where I'm moving forward. So 1, 0, 2 are my moving forward. And I have some where I'm moving backwards, a -1 and a -4. So I'm going to put those outcomes as my first step. Now, you don't want those outcomes to be too complicated. You really want them just to be, you know, some positive values and some negative values. You don't want it to be too complicated. So mine's too complicated as it is. All right, so I'm gonna put all these values on there. So I'll just start down here. -4, 1, -1, 0, and 2. And then I need the probability of each of those. And in my game, I'm going to take one out, look at it, then I'm going to move that many spaces, and I'm going to put it back in. If you do something where you make cards, or you do something where you're drawing like this, you're going to want to do it with replacement, so that your probability stays the same each time. Because the minute you're doing it without replacement, all of a sudden the probability gets too complicated. Excuse me. So don't do something where you take it out and leave it out. because then all of a sudden it gets super complicated. Then you've got to start looking at all those different ways that you could pull it out, and that's just too complicated. So I'm going to advise you, in your game, whatever it is, do it with replacement. It's just going to make it easier on you. And on me too. So this game, just make it so the probability stays the same each time. So whether it's cards, you shuffle it each time, or you pull something out, probably the easiest thing to do would just be to make a spinner, or to make some sort of dice where you're rolling each time it's the same probability. Okay, so here I'm going to find out the probability of each. So what is the probability that I get a -4? How probable is it that I get a -4 out of here? When I'm drawing it, what's the probability that I get a -4 out of there? Oh, good. It's 2 flags out of the total of 16 flags. So you're exactly right. 2 out of 16, or Jasmine just said 1/8. Good. I didn't make my chart quite tall enough. So 1/8. What's the probability then that I get a 1? What's the probability I get a 1? It's that same thing, right? It's just 2 out of the 16, so it's still 2 out of 16, or 1/8. 2 out of 16, 2 out of 16. Then what about this? What's the probability that I get a -1? Well, it's again 2 out of 16, so it's still 1/8. So 1 out of every 8 turns, I would expect to go backwards 1. And then what about the probability I get 0? What's the probability I get 0? Good, it's the same thing, 2 out of 16. So far it's pretty boring, they're all the same. 2 out of 16, or 1/8. That I go 0. Okay, last but not least, now this one. What's the probability then that I get to move forward 2 spaces? It's 8 flags out of a total of 16. So yes, exactly, 8 out of 16 is equal to 4 out of 8, which is also equal to, 1/2. But I like leaving it at the 4 out of 8 just so they have a common denominator. That's probably a smart way to do it, just so they have a common denominator on there. But you're right, it's also 1/2. Okay, now when I was getting ready to create this game, when I got ready to make my little sticks, I did this part first. I decided first how many of each I wanted and what I wanted my probability to be. And it helped me decide by doing this, because it was 1 out of 8 that I was doing it, I knew that the number of these I needed to make needed to be a multiple of 8. Either 8 or 16 or 24, something so that it kept my probability along with that. It made it easy for me to find the probability of them afterwards. So I started with this. And then I made sure that that was moving in a positive direction. You want your expected value to be positive, because if you end up with it negative, the likelihood that it's very probable then that the game never ends. In fact, you just keep going backwards. You don't want that to happen. You want your expected moves to be moving forward each time. So I would actually start here and then build from that. And that's what I did when I was creating this thing, is I first did some of this and I played with it to see until I got what I wanted. So here, now, to find the expected value, of course, all we do is take our number of moves and multiply it times our probability. So on this one, we move backwards 4 spaces, and our probability was 1 out of 8. I bet you can tell me what the expected move is. See if y'all can come up with what is the expected move for this game. I'm going to do it here as you do it there. We'll see if we get the same thing. See if you can beat me to it. is taking my expected moves times the probability of each one of those. They all have that nice common denominator right now, so I'm going to leave it, just multiply across. See if you're getting the same thing I am. Let's see. This plus 1 and that minus 1 becomes 0. That's a 0. So that just leaves me with 8 minus 4, which is 4/8 or 1/2. So that means on average, I'm just going to move half a space each time. That's what that says, on average. Now there's not a half up there. I'm never going to go half a spot. But on average, we're just going to go half a spot. So if on average, I'm going to go half a spot, which by the way, what I did when I was creating the game was I started here. I said, what do I want to do? And I just started making up some things. I was like, what if we move backwards 5 and go forward 3 and go backwards, 2 and go forward 1, and let's just make our probability. I was just making stuff up in the beginning. And I multiplied it and I saw what my expected value was. And then once I got one that I was happy with, then I used that. So once I got one that, okay, I don't like this one for whatever reason. It was negative, or this one was too little, or this one's too big, or whatever it was. Once I got to that, then I made this and I said, okay, well, my probability is 1 out of 8, so I need at least 8 sticks, and one of them to be that -4. So I would start here, play with it, decide on your expected value, and decide what your moves are going to be, and then what your probability is going to be. Then, if you do something like you have -4, and then that probability is something like 1/4, then if you're making a spinner, then you need to have 4 pieces to your spinner. If you're making a die, then you need to have 4 pieces to your die, 4 sides to your die. If you're drawing cards, then you need 4 or 8 or 12 or 16 cards. So this bottom denominator helps you decide on the number of things that you're doing it out of. So I would literally start with the probability distribution, come up with your expected value first, and then from that, decide on your moves. So I have 16 little flags because that was a multiple of 8. And then I figured out from there, well, if I want 16 flags, and it's a multiple of 8, well, that multiplies by 2, this multiplies by 2. I need 8 of my flags then to be 2. Then I started the creation of the whole thing. All right, so your job is to create that probability distribution, tell me what your expected value is, and then create a board. Now, I need to know how many turns should I finish in. So that's the next part of it, is to figure out then how many turns should I finish in. So if I'm just moving half a spot each time, if I'm just going half a spot each time, and there are 10 spots on my board, how many moves should it take me? How many moves would I expect this game to take? That's exactly right. If I'm going half a thing each time, then I would expect to finish the game in 20 turns. So I expect to take 20 turns. What if I were going there and back? Then how many turns would it? Good, it's 40. That's exactly right. You just double it to go there and back. So you can decide, I decided on a half because I had this little bitty board. And I was like, okay, 20 turns is not an unreasonable amount of time to play. I could play with some kid for 20 turns and finish. And we might finish faster. It might take us longer, because just because that's what we expect to happen doesn't mean it's going to happen. But that at least gives me an idea of it. Okay, so these are the things you're giving me. You're giving me this probability distribution and your expected value. You're going to have to do the game and tell me how many turns it's expected to be. Then you're going to empirically tell me what happens. So in other words, you're going to actually have to play your game with someone. So find somebody you're quarantined with that you can play with. So if you have a child in the house, this is a time where you get to spend time with your child. And then, but if you don't, if you've got a parent in the house, then this is a time that you wrangle them and you say, okay, I'll wash dishes if you'll play this game with me for stats. Or if you're home alone and you're just isolated completely, then virtually you're going to get to connect with a friend via Facebook Messenger or Skype or something. Get on Discord and play the game. But play the game, or you can get out a stuffed animal and you can play with your little stuffed animal, something, but you're going to actually play the game. Okay? Find somebody, your dog or your cat, somebody you can play the game with. Then you're going to actually play. I'm going to play with my Dr. Pepper can here. Okay? Dr. Pepper can and I are going to play. Hey, Dr. Pepper can, I'm going to beat you at this game. I'm going to race to the finish. I'm faster. I've been training. I'm going to beat you. Okay, so here we go. So I'm going to pick something. Here's mine. I got 5 minus, or square root of 25 minus the square root of 9 is 5 minus 3, which is 2. I get to move forward 2 spots. So I'm going to go forward 2 spots. 1, 2. Okay, so me, on my movement, I went forward 2 spots. Now, DP, he gets to draw. So DP draws, and he has to figure out the math. Negative 12 divided by 6 is negative 2, plus 4, 20 divided by 5 is 4. So negative 2 plus 4 is 2. He too goes forward 2 spots. Right now we're in good shape. So DP went ahead 2 spots. Now I get to go again. Negative 9 plus 3 is a negative 6. Minus 2 is a negative 8. Plus 4 is a negative 4. Oh no! I went backwards 4. Oh no! Back to the beginning. Oh man. Oops. You know what I'm not doing is putting it back in. Everybody needs to put it back in. It's true. The quarantine has made us go crazy. Okay, you get the idea that what I'm going to do is actually play the game all the way through. 20% times 10. What's 20% of 10? It's just 2. Dr. Pepper gets to move ahead 2 spots. Oh, put it back in with replacement. Then pull it back out again. Yeah, it is with replacement, Jasmine. I shouldn't have put it back in. Negative 7 plus 6 is a negative 1. Oh no, I have to go backwards again. I can't go backwards. I'm already back at the beginning. Put it back in. Pull it back out. 10 minus the negative 8, the absolute value of negative 8. So 2. Dr. Pepper is winning. He gets to go ahead at 2 again. 1, 2. Oh, man. Okay, my turn. 2 minus the absolute value of 6. Oh, I have to go back 4 again. Oh my God, this is horrible. Stupid Dr. Pepper is beating me. Dr. Pepper gets negative 12 divided by 6 is negative 2, plus 20 divided by 5 is 4. So 4 plus a negative 2 is 2. He gets to go ahead 2 again. 1, 2. Oh my goodness. Why am I losing so badly? Negative 5 plus 6 is 1. Plus 1. Yay! I get to move ahead 2. Yay! Can I catch him? Maybe he'll go backwards this time. Maybe he'll go backwards. Negative 7 plus 6. He went backwards 1. He went backwards 1. I'm going to catch up to him. I'm going to catch up to him. Hey, my turn, my turn. 15 divided by 3 is 5. Minus 4 is 1. I get to go forward again. I get to go forward again. Yay! Oh, he keeps getting the same one. Negative 12 divided by 6 is negative 2. Plus 4 is 2. Oh, he's going to beat me. Oh, I get to go forward 1. Oh no, he's almost there. I need something that says like jump to the finish. 4 minus 5. Oh no, backwards again. This is horrible. This is, by the way, this is just me. Every time I play a game, I lose. I don't care if I'm playing against the Dr. Pepper kid or not. This is what happens. My luck is just that way. See, I'm going to draw out another one. 16 divided by 4 is 4. Minus 3 minus 1 is 2. So 4 minus 2 is 2. We won! No! Congratulations, Dr. Pepper. Good game. Good game. Good game. Here. Definitely good game. Good game. Okay, so let's just look and see what actually happened then. So we said that we were going to move and it should take us 20 turns. But really it just took us 1, 2, 3, 4, 5, 6, 7 turns. It only took us 7 turns. Then let's look at what empirically, then what were my outcomes? Notice that empirically my outcomes didn't match what happened theoretically. So here empirically, here's my empirical data. Empirically, I only got a 2 or a negative 4 or a negative 1. Those were my only outcomes. 2, negative 4, negative 1, oh, and 1. I did get to go forward 1. And then empirically, what was the probability that I got a 2? 1, 2, 3, 4, 5, 6, 7, 8. We had 8 out of a total of 1, 2, 3, 4, 5, 6, 7 doubled is 14. So yeah, 8 out of 14, or you're right, that's just equal to 4 sevens? 4 sevens, right? Then, yeah, just the total. And then the negative 4s, well, there were 1, 2 out of those 14. I'm just going to leave it at 14 because here in a minute I may need it to be to 14. And yeah, Mr. Simpson's right. The larger the sample size, the better. Then the negative 1, well, we went backwards 1, 2, 3 times, so 3 out of 14. And then forward 1, we just got to do once, so 1 out of 14. So empirically, yeah, poor 0, he didn't get any. So now empirically, we just multiplied the outcomes times the probability. The outcomes times the probability. So we end up with 16 fourteenths minus 8 fourteenths minus 3 fourteenths plus 1 14th. for a total of, let's see, that's 8 minus 3 is 5 plus 1 is 6. I got 6. Well, y'all check me to make sure that's right. Or simplifying, that's 3/7. So according to this, we actually did the expected value of the expected move was 3 out of 7 rather than that 1/2 that we got. So empirically, whereas this is in theory. So notice the theoretical doesn't match my empirical. Now, if I were to play this game more and I kept collecting data over time and collect a lot of data, then my empirical should match my theoretical. So if I keep playing this with Dr. Pepper every day and we keep collecting our data, then our empirical should get closer and closer to that theoretical. So that was a fun game. So that's exactly what I'm looking for. I want you to come up with, what's your expected outcome. I would do that first so that you're making sure you're actually moving forward and not going backwards. And then create your game around that. So there's the nice, easy foot races. And instead of using the spinner, I just made little checkered flags. So you could do something like that, make like cards or something that you're drawing. But if you do, the big deal with that is make it with replacement so that the probability is not changing each time. Otherwise, it just gets too complicated. So don't try to make this complicated. I don't want to make it complicated. It's complicated enough as it is. Then my Swift Mages game. In this one, I used a spinner. So in this one, we've got Swift Mages here. And on it, it's not a board game. Rather, I just use things I had around my house. Y'all all have toys like this around your house, right? Okay, now I'm going to play my Swift Mages, or let's just look at my Swift Mages. So the Swift Mages game is nice and simple. First, you get to choose your pieces, and then your job is just to get to the Dark Wizard so you can defeat him. So, really it looks complicated. This game looks really complicated, but it's not. It's super simple. I'm just moving my mage from here to the Dark Wizard. Or on this end, I'm just moving my mage from there to the Dark Wizard. That's all I'm doing. Nice and simple. So it looks complicated, but it's not really. Okay. Then I just created a spinner that's always going to go down while I'm holding it up. But if I fold it flat, it actually works. And the choices are entangled, lose this turn. So if I'm losing this turn, I'm really moving 0 spots. So, you read that and you go, okay, that's really just 0. I'm not moving anywhere. You can't see the board? So there's my board. And so all you're really doing is moving the mage to the Dark Wizard. And then this one, Pact with Demons, go forward 2 spaces. So, you get to choose a demon, make a pact with them, and you get to move forward 2 spaces. Then a Treant, guide your path, and you get to go forward 3 spaces. So Treant, guide your path, and you get to go forward 3 spaces. Here a spider approaches, so you run back 1 space. So when the spider approaches, you have to go back one space. I know how y'all all feel about spiders. And then you get attacked by rats, but you're saved by a marauder, so you get to go forward 1 space. So the rats are attacking you, but a marauder comes, and you get to go forward 1 space. So, here we go. This is really just 0 if I lose a turn. Here, I'm going forward 2 spaces. There, I'm going forward one space. I'm running back one space. So running back one space is that -1. Yeah, well, the pirate helped us this time instead of hurting us. And then he killed the rats instead. And then the treant moved us forward 3 spaces. So those are my outcomes. And then the probability of each outcome. What is the probability of each outcome? Oh, you're right, I have to write lower because I moved my camera down. Thank you. Can you see that? Okay, so now what is the probability that I get 0? What's the probability that I get 2? What are those probabilities? Good, 1/5 is my probability because there's 5 equal pieces, 1, 2, 3, 4, 5. So each one of these is just 1/5. So you can see on the spinner, it's nice and simple. My probability is just the same for each one of them, nothing complicated about it. Or if you were to make a dice, that would be the same way. You know, you make a die and put your little movements on it, then that could be nice and simple too. By the way, I was tempted in this game to do something on the board like go back to your starting spot. That's a temptation, right? We've seen that in games before where you say go back all the way. But that changes your outcome. Like when I go back, am I going back 1? Am I going back 2? Am I going back 4? All of a sudden, again, that's too complicated. I don't want you to do anything too complicated. So try to keep it nice and simple where your outcomes are just things like 0, 2, 1, -1, 3. You know, it's not too complicated. Notice my outcomes here are not too complicated. So it is tempting when you're making the game to do something like that. But just keep it nice and simple. Keep it nice and simple. Think Chutes and Ladders or Candyland. You know, don't think Sorry or Monopoly. Nice and simple. Okay, so then we just find the expected value of it. And the way we find that expected value is just multiply. 0 times 1/5 plus 2 times 1/5 plus 1 times 1/5 minus 1 times 1/5 plus 3 times 1/5. And then you just multiply to find that expected value. So 0 plus on average, what's going to happen? So I've got 3 minus 1 is 2 plus 3 is 5. So 5/5. So on average, I should move forward 1. So notice in this game, on average, I was just moving forward 1/2. But on this one, on average, I'm moving forward 1. And this one only has 1, 2, 3, 4, 5, 6, 7, 8 spots on it. So if I'm moving forward 8 spots, how many turns should it take? It should just take 8 turns. So this is your job. And my advice is start here. Start with this. Decide on your numbers and your probabilities before you begin. Maybe you can visualize, okay, I want to do a spinner. What would be a nice way to break it up? So what would my probabilities be? You know, think about it ahead of time and decide on your expected value first. And you want your expected value, well, it depends on how long your board is. You know, if you've got 100 spaces on your board, then for sure you want your expected value to be a little bit bigger. But if your board is little, then you're going to want your expected value to be something little. So think about all that when you're creating it. But start with that expected value. And then create it, and then play it with someone. And when you play it with someone, document each turn what your outcome is, and then find the actual empirical, the empirical one. Math made simple. Let's some math. Thanks for watching.